Chapter 8, ladies and gentlemen, is going to cover multiple choice items. Always pick answer C and you'll be right about 25% of the time. Well, maybe the law of averages will catch up with us as we answer multiple choice kinds of questions. And so let's take a look at the multiple choice question and see how it's created and what it can do for us. There are some preferred ways to test, and we can test achievement-oriented outcomes. If we're doing a test like the compass test or ACT test, SAT, something like that, where we want to see what a student knows. Multiple choice items are a wonderful way to get that done. The compass test doesn't always use a multiple choice format because of some of the types of questions that they have, but it does utilize some. Probably the one that I'm most familiar with that uses multiple choice is the work keys assessment. All of their questions on the work keys test are multiple choice. So it wants to kind of know what you know, and so they work very, very well to get that done. They are also easy to score. There's only going to be one answer for you to choose. Then they are easy to analyze statistically. If we want to check out to see just how well our test is put together, multiple choice questions let us do that, and we'll talk about that later on in the chapter. But we can easily tie them to learning outcomes. What kind of goals, objectives do we have for that particular lesson? We can tie our questions directly to those utilizing a multiple choice item. And they are really flexible. We can use them just as a standalone question where you will read the question and then pick the right answer, or else we can tie them in as some of my test banks on some of my textbooks tie them with graphics, and also the work keys test. There are a lot of things that, especially with the locating information test, where students will have to find things within the graphic and then answer and get the right answer with the multiple choice question. So we can use them in a lot of different situations. And we can create items that match our outcomes. So we can kind of customize our test items to look at the objectives that we've got in place for us, that we want our students to be able to know. And then we can write them at any level of Bloom's taxonomy, which deals with learning styles. We can talk about very cerebral kinds of learning, certainly higher order kinds of discriminations that we want students to make, or else we can just get down to real basic types of answers that are very, very easy and in a way that other questions can't. Our multiple choice questions are going to have three distinct parts. The first is the stem. It's basically the premise for the question and comes before the alternatives. We can kind of also look at that as the question itself. But we set up what it is the student is going to be asked to know in that STEM. And then right up front we've got a correct alternative. This is the answer to that question that's going to complete the STEM. Now once we've got our STEM and correct alternative, then we can kind of fill in with what your book calls distractors. These are going to be the incorrect responses. Now, they are designed to distract the test taker. But one of the things that's nice about the distractors is they should be plausible. They should be close to the answer. We're going to have to make the student think. You know, we don't want some question that is, or answer that is, you know, has nothing to do with the question. We want our distractors to be close so that the student has got to be able to kind of discriminate between the answers to a great degree. We want to make them work on those answers so that they have to know the material. Now, your book gives you some guidelines for writing multiple choice items, and so we're going to kind of go through these real quick. List your alternatives on separate lines, one right after the other. And so you've got your STEM at the top. Might look something like this. You know, it's typed up there in paragraph form with a period, and then down below there you've got one A, B, C, D, and E. And so you kind of indent them out there, and so that helps the students to know these are my possible answers right there. Each of our items should clearly align with the learning outcome. When we create our test, we just look at what it is we want our students to know and build our test around that. The position of the correct alternative should vary. You know, all of the answers shouldn't be in some kind of sequence. They ought to be random. You know, not every answer is going to be B, not every answer is going to be D, or else first question the answer is A, then the second question B, right on down the line. We want to be random. And so that sometimes takes a little work. But of course, with a word processor, we can cut and paste and move our possible answers and our questions from one position to another very, very easily, so that we're not in some kind of sequence there. Obviously, you want to use correct grammar, since you're going to have to kind of write out the question and also, in some cases, write out the answer. The STEM should be self-contained. It's like a complete statement. Sometimes you'll see questions where they'll have a blank in the multiple choice question, where in case you're asking about a definition, and then your answers are the words. I've used them before, and that's kind of not exactly a self-contained question. It's incomplete. But, you know, I think it works. Negatives, absolutes, and qualifiers are no-nos. We don't want to kind of give them the answer. And certainly you don't want to go ahead and write questions out that are kind of obvious as to which answer is correct. And that kind of leads into, like we said before, your distractors ought to be plausible. They could maybe fit, but you want to make that student work for that answer and know that material so they can get the right answer. And all of your test items ought to be independent of one another. That means that, you know, you're testing one thing at a time, or it's not like you have a series of questions that might be Now, I think an exception to that, and I think a very appropriate exception to that, is whenever you might use a graphic or a photograph where you can have a series of questions that may make a student kind of identify some parts of something. I think the only thing that you and I should never have to do is have that picture or graphic that they're using on one page, and they've got to flip back and forth to answer the questions. We ought to be able to at least maybe put that graphic and set the test up where, graphic may be at the top of the page and say the next 4 questions refer to illustration whatever, and then you put your questions underneath that so that they're right there, everything's right there for them to answer, so they don't have to worry about flipping back and forth and rustling pages and getting distracted. But I think that you could really make effective use of kind of dependent questions with a graphic. And of course, we see our advantages and disadvantages, and we've looked at a lot of them. They can be used to measure learning outcomes at almost any level. They're easy to understand if you write them well. They de-emphasize the writing skills. Don't have to do a whole lot of writing, just be able to put the letter or circle the appropriate answer in the blank. They minimize some guessing. So like that, you have to know the answer in order to get it right. And obviously they are the easiest ones to score. And of course we can, as we're going to see, we can do some analysis on them to see if they do exactly what we've designed them to do. Now, disadvantages, they take a long time to write. If we're going to put them together and make them work, then we're going to have to sit down and align those questions to our learning goals, and that's going to take some time. And good ones are difficult to write, and because of that limitation, they kind of limit our creativity. We have to kind of just stick to stems that focus on our learning objectives. And then, this is probably the worst case scenario. They have may have more than one correct answer. If we're not careful with our stems, if we just sit down in the book and just kind of write word for word from what's in the book, and that the student can say, well, look, this is what it said. This is straight out of the book. And the author might have said one thing in one section, and then it says the same thing or something a little different in another section, and you and I put that in as our responses, and we can wind up having to defend the test and start throwing out questions. So just take your time with your responses. So there's obviously just one correct answer. So now let's take a look at some analysis that your author talks about that we can use to analyze some multiple choice questions on our tests. Now, I'm going to be quite honest with you, I have never done this. But yet, there are some people who do this all the time. People from WorkKeys, people from all of these companies that put together standardized tests. I guarantee you that they are always looking at multiple choice questions to look at their validity. So let's take a look at something called an item analysis. An item analysis is pretty much what it says. You look at all of your test items and check them out. Now, we want to know, by doing that item analysis, how well our items can discriminate between those who know the material and those who don't. Simple as that. Why would we go through all that trouble? Well, do we have some people who are good guessers? You know, for example, I used to do the compass testing at our school. I had people who had college degrees that did not pass the compass test. I had people who did not finish high school that made their scores. Now, the only thing that I can attribute that to is that maybe the ones who had a lower educational level just had a good day guessing on questions. Because if they didn't know the answer, they had at least 25% chance to get it right. 1 out of 4 shot. Now, what about the college graduate that didn't get the job done? Chances are they probably read and reread the question and pretty much convinced themselves that the right answer was wrong. And I'd always kind of give them some advice whenever they'd go out there and say, well, I got to go retest and all that. I said, look, don't spend a lot of time with these things. Your first answer is usually the right answer. Don't talk yourself out of a right answer. And so that's one of the things that can happen with these multiple choice questions. And so what you do is to create a high and a low group from those taking the test. Those that scored high on the test and those that didn't do too well. And then you generate 2 indices for each item. You look at a difficulty index and a discrimination index. What in the world are those 2 things? Well, let's take a look. We take our 2 groups, our high and our low, and we rank order the scores from highest to lowest. All right? We take the highest score. You know, if 20 people took the test, we take the highest of those 20 and just write them down from highest to lowest. Simple thing to do. And what we do is take about a quarter, or 27%, of the high side group, and then select about a quarter of those at the bottom. All right? Then we take a look at each one of the questions on the test, one at a time. Now, we don't look at the entire test. That's going to take a long time, especially if we got like 30, 40 questions. The difficulty index. We want to find out how difficult is the test item and answer the question, how many people got the question right? Now, obviously, can people that, you know, failed the test, didn't get made a less than a passing grade, get an item right? Sure they can. They just missed other questions. And so we just are comparing how many people in both groups answered or got the right answer for each item. They have a formula here, a mathematical formula. D is equal to N of H plus N of, looks like I, divided by T. Now, what in the world is that? Well, N of H is the number of correct responses in the high group. Let's say 20 people took the test, and we said, we took like the top the top 5, and let's say if 3 of them got it right. And then we took our lower 5, and let's say 2 of them got it right. 2 out of the 5. And so we just add that up for a total of 5. And then we divide that by the total number of responses to the item. And so that would be what? 20. Because 20 people could take the test. Now, your reporting difficulty. It's an easy thing to do. You report the percentage of the individuals in both the high and the low group who got the test item correct. So you got a 50 item test. You got 22 right in the top one. You got 14 right from the low group. The difficulty, if we add the two together, that would work out to be what? 36. And it's a 50 item test. That would be equal to 72%. That would be 0.72. Then we just multiply by 100. All right, so what? Is that good, bad, indifferent? Well, let's see. Let's look at our discrimination index. What this tries to do is to tell us how effectively does the item discriminate between the high group and the low group. And so we utilize a different formula to some extent. We take the number of the high group and subtract the number from the low group. Then divide that by half of the total number of correct responses. And that's the key. Half of the total number of correct responses here. And so this is the difference here. We're comparing how many got it right. And so the discrimination is reported as a decimal and can be either positive or negative. And remember, since we are subtracting, we could subtract a larger number from a smaller number and wind up with, let's face it, more people on the low side could have missed the answer than those that got it right in the high group, and so we wind up with a negative value. And so what's happened is that if it's positive, more people in the high group than in the low group got the item correct. And this is what we want. It's measuring the question's validity, that it measures what we want. If it's a negative discrimination, then more people in the low group than the high group got the item right. And so it is not discriminating between the groups. In fact, it's measuring something maybe different. Maybe it's one of these questions where, if you don't know the answer, you can at least guess and get it right. We wanted to be able to discriminate between those students that know the information and those that don't know it. That's what we're doing. Now, the perfect item has two characteristics. Now, obviously, there's probably no perfect question, no perfect test, but if there were, the difficulty would be 50%. That half of the people got the item right, half of them did. So getting back to our example of the 20-point test, if 20 people take the test, then 10 of them get it right, 10 of them get it wrong. And that would be a discrimination of 1. The high group gets the item correct, the low group gets the item wrong, consistently. But remember this, the discrimination level will always be constrained by the difficulty level. What does that mean? Well, the degree to which our students are going to be able to discriminate amongst the answers will be constrained by the level of difficulty of the question. And so these things affect each other to a great extent. And so let's take a look at the difficulty and discrimination indexes. They've got a little number line here where we have like 4 questions here. This one, question number 1, has a positive discrimination level of 0.5. And this one, number 4, a negative 0.5. Basically, more people got it wrong than right. And then we've got these two, questions 3 and 2, on the high side of the difficulty level. And so what in the world does this graph mean? Well, item 1 is not a bad item. 25% got it correct. And our discrimination level, half got it positively discriminated because it is a positive number. Number 2 might be a little bit too easy. 75% of the people got it right. Remember? Let me go back here real quick and see where our numbers were. Okay. So 1 was right here. 2 was right here. There's 3. There's 4. Alright, so here we got 75% of the people got the thing right. So maybe it doesn't discriminate. But item 3 is the big problem. 75% got it right, but it negatively discriminates. More people on the low group got it right. So that's a question we need to look at and check out again, and maybe rewrite, or maybe throw it out, one of the two. So when it's all said and done, items fail to demonstrate because the item writing rules of thumb have been violated. And what are those? We ought to have one clear correct answer on our multiple choice questions, and we need some good distractors, some that are plausible that the student's going to have to work to get the right answer. We want to use complete sentences in our question, and then we want to keep away from negative words in the stem, which will kind of focus them on the answer. All of our items should be independent, but like I said, I think there's some room for flexibility there. Complex tests Item format should not be used. We don't want to make these things so complicated that students are going to have a hard time taking the test. And our alternatives should be grammatically consistent. That means proper English, good grammar. And our stems, and this is, I think, the most important one, our stems should clearly state the problem. That's why you and I need to spend some time working on these questions. We just don't want to throw them together all of a sudden and get them done.